Hello everyone, in this video I want to talk about how we can graph some logarithmic functions. So now before we get started, remember a log function is the inverse of an exponential. So knowing that fact is going to help us to be able to graph these. So as always with different types of functions, we always want to start off with what's the parent function, because all other functions are just transformations of the parent function. And so we're going to see transformations in the next video that we do here in this channel. So the parent graph for a logarithmic function, the graph of f of x equals log base b of x is shown below. We're going to have these two examples down here for when b is greater than 1 and when b is between 0 and 1. So because f of x equals log base b of x and g of x equals b to the x are inverse functions, and that's what we just said, right? Because this function right here is our exponential function. So logs and exponentials, those are our inverses. The graph of f of x equals log base b of x is just the reflection of the graph of g of x equals b to the x in the line y equals x, okay? So we are just reflecting the graph over the line y equals x, essentially. And that's what happens for an inverse, right? Because we know from past courses in geometry, if you reflect over y equals x, that's just like switching x and y. And we know from algebra, inverses are switch the domain and the range, or switch x and y, right? So that makes sense. So if we take a look at these two diagrams, on the left we see when b is greater than 1. So if we have log base b of x, and let's say b is 2, 3, 4, something like that, so maybe like log base 4 of x, this is what our graph is going to look like. So our yellow graph here is the graph of our log function. So when we graph this, we can use the exponential function g of x equals b to the x to give us the log functions, right? We could graph, you know, for example, if b were 4, we could graph f of x equals 4 to the x, figure out what our x's and y's are, and just switch those, right? And that would give us our log function, log base 4 of x. And then you could just erase what you did for your exponential. So if we remember for exponential, when we do have a b value that's greater than 1, then this is what our graph looks like, okay? Now, whenever b is between 0 and 1, so some kind of fraction, 1/2, 1/3, something like that, we know that our graph now is decreasing towards positive infinity. And once again, with exponential functions, remember our x-axis is our axis of, not our axis of symmetry, our asymptote, right? Which means our graph is going to approach the x-axis, but it's not going to cross it. And so if we think about that, now we're taking the inverse to get the log function. Well, now the y-axis will be our asymptote and not the x-axis. So that's what we see here, right, with our yellow graph. It is approaching this y-axis, right, down here, but it's never going to cross it. So now over here, back to on the right side of the screen, we have whenever b is a fraction. So now we're going to still, it's an inverse, so reflect over y equals x, but now our graph is going to approach positive infinity in terms of the range as we approach the y-axis, okay? All right, so it says, note that the y-axis is a vertical asymptote of the graph of our log function. The domain of our log function is x is greater than 0, and the range is all real numbers. Because remember, for our exponential, the domain is all real numbers, and the range is values that are greater than 0, right? So we're just switching that for our log functions, okay? So we're going to do two examples, one where b is greater than 1, like on number 1, and one where b is between 0 and 1, like on number 2. So like we said initially, right, a log function is an inverse of an exponential. So to help us graph the log function, let's graph the exponential function first, and then just switch the x's and y's. So for number 1 and number 2, notice that we have this diagonal line in here that's a dashed line. That is my line y equals x. That's the parent function of a linear function. And that is essentially my line of reflection here. So I already have that on there for us to help us see how these two functions are being reflected. So for f of x equals log base 7 of x, we could figure out y equals 7 to the x power. That would be our exponential. That would be the inverse of this log function. So I know that anything to the 0 power is 1, 7 to the first power would be 7, 7 squared is 49. Now if I worked backwards, negative 1 would be 1 over 7, and negative 2 would be 1 over 49. So let's plot this really quick. So we'd have 0, 1, 1, 1, 2, 3, 4, 5, 6, and 7. Obviously 249 is not going to fit on my graph here. And my other points are just really close to the x-axis. So my graph, my exponential, would look something like this. Okay? All right, so now all we need to do is take our x and y values and just switch them. So for -2 comma 1/49, this would be 1 over 49 comma -2, right? Because this is going to represent my log function, f of x equals log base 7 of x. So now we would have 1 over 7 comma -1, 1, 0, 7, 1, and 49, 2. So let's plot those and see if we can see how this graph has been reflected from the exponential over the line y equals x. So -2 and 1/49. So -2, so 1, 2. 1 over 49 comma -2. So 1 over 49, very close to the y-axis, -2, so maybe somewhere around in there. 1 over 7, -1. Sorry about that. 1 over 7, -1. So maybe just somewhere around in here as well. 1, 0, right here. 7, 1, 1, 2, 3, 4, 5, 6, 7, and 1. And obviously 49, 2 is not going to fit on our graph. So now we can draw our graph this way. Let me make that a little bit better. There we go. All right, and so now we can see how our y-axis now is our asymptote, right? The graph is going to approach but not cross the y-axis. And so right here, this would be our graph, f of x equals log base 7 of x. And so if I wanted to, I could take away this exponential here and my axis of symmetry, which was my line y equals x, okay? All right, let's take a look at number 2. Now, for number 2, we have y equals log base 1/2 of x. So if we start the same way, this would be like graphing y equals 1/2 to the x power, and then reflecting it over the line y equals x, or essentially just finding the inverse. So anything to the 0 power, once again, is 1. 1/2 to the first is 1/2. 1/2 squared would be 1/4. And going back the other way, we would have -1, 2, and -2, 4. So we can go ahead and plot this. -2, 4, 1, 2, 1, 2, 3, 4. -1, 2, 0, 1. 1 would be 1/2, and 2 would be 1/4. So we're approaching now on the right side of my graph, the x-axis, and getting closer but never crossing, okay? Now, same thing for our log function. Let's just switch x and y. So we would have 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4, 2. And this would be y equals log base 1/2 of x. So 4, 1, 2, 3, 4, -2, 2, -1, 1, 0, 1/2, 1, and 1/4, 2. Okay, so now once again, remember our asymptote is our y-axis, and so our graph is going to approach but not cross that y-axis. So that's what our log function would look like. So just like we did on number 1, we could take away this exponential, and we could take away our line y equals x, and that is what our graph would look like. Okay, and that's how you can graph some logarithmic functions.